All right, our next topic is this one. Establish and use the sine and cosine rule and find the area, this is the area formula of a triangle. So we're going to talk about the sine rule and cosine rule first.
Mm-hmm.
So sine rule and cosine rule applies to any triangle that may not necessarily be a right-angled triangle. Okay.
Yeah.
So let's say, and by convention, we use capital letters for angles. Okay. And the side that is opposite to this angle A is little a, and this one is B, and this one is C. Do you understand?
Yeah.
So that's the convention. And what we do, the sine rule is given by A over sine A is equal to B over sine B, C over sine C. So what it means is this: no matter what type of triangle you have, A over sine of A would equal to B over sine B and would equal to C over sine C. They all have the same value. It's a pretty interesting result, isn't it?
Yeah.
So let's talk about an example. If you have a triangle, this is 90 degree, and this is 5, and this is 4, and let's say this is 3. This is famous 3, 4, 5 triangle. And it is a right angle triangle because it obeys Pythagoras theorems. For example, 3 square, 4 square equals 5 square, isn't it?
Mm-hmm.
Therefore, this must be a right angle triangle. And if I just figure out this angle and this angle, well, this angle is, I can just do either inverse sine, inverse cos, inverse tan. What would you like to do? Inverse sine, inverse cos, inverse tan?
In the sine.
Inverse sine, okay. So inverse sine of what over what gives you this angle?
Inverse sine of 3/5.
3 over 5, that's right, because that's opposite over hypotenuse, right?
Mm-hmm.
So that gives us 36.87. 36.87. Yep. So if
Yeah.
I do one, now it's pretty easy to figure out this angle here. 180 minus 90 minus 36.87. That gives us 53.13.
Mm-hmm.
Now let's see if this rule works. So I'm going to do 5 over sine 90. Is that really equal to 4 over sine 53.13? Is it really equal to 3 over sine of 36.87? Well, let's
Mm.
try. Well, sine 90 is, by the way, 1.
Yeah.
So that's 5 over 1, which is 5. So if I do 4 over sine of 53.13, oops, what's wrong? I need to close the bracket. That's almost 5, isn't it?
Yeah.
That's the reason for that is because of
The decimals.
decimal rounding up. Yep, that's right.
Yeah.
And 3 over a sine of 36.87. So that's giving us about 5, isn't it?
Yeah.
So the rule is working, and this works not only for right angle triangle, but also for the non-right angle triangles like this stuff here. Okay.
Yeah.
Now, cosine rule is an extension to the Pythagoras theorem. You know, Pythagoras theorem is c squared equals to a squared plus b squared, and this one works when you have c as the hypotenuse, and that's right angle. This is like a and b, right? So
Yeah.
that's like, this is special case of cosine rule. Now, cosine rule goes like this: c squared is a squared plus b squared minus 2ab cosine c. That's the cosine rule. But we can also apply that to a square, okay? So a square is b squared plus c squared minus 2bc cosine of a. Now, can you tell me what b squared is?
B squared would be A squared plus C squared
Minus?
minus 2 C, oh yeah, AC.
Yeah.
Cos B.
Cos b, that's right. So that's cosine rule. So this is an identity. So for example, let's see if that worked for this one. So is 5 squared the same as 3 squared, 4 squared? Minus 2 times by 4 times by 3 times by cosine of 90. Just keep this in your mind. Sine 90 is 1, but cosine 90 is 0. Sine of 0 is 0, but cosine of 0 is 1.
Yeah.
I'll show you later why that is the case. Or maybe I'll show you now. Remember how we talked about unit circle?
Yeah.
Think about this case where you have this angle is 0. So see how this triangle has finite angle, but imagine this is 0 angle here, and this is a 1, 1, and this point here is x, y. What would be the value of x, and what would be the value of y if this angle is 0?
It'd be 0 and 2
So
or
you
something.
see how this one is 1 here?
Yeah.
X value is 1, but the y value, it doesn't really go up. So y value
Yes.
is 0, x
0.
value is 1, but x is known as what? X is cosine theta, and theta is 0, right?
Yeah.
And y is sine of 0, isn't it? That's why sine 0 is 0, cosine 0 is 1. Like so.
Oh,
Sine
okay.
0, cosine 0 is 1. Now imagine we elevate the angle so that we end up getting this sort of triangle. So it's very thin triangle, and that angle inside here. So let me just consider this one. So this is almost 90 degree here, right? But if we go even further and get it exactly 90 degree, then we get a triangle, which is just a line. It's not really a triangle.
Yeah.
But in this situation, you can see that x is 0, but y is 1, isn't it? So that's 1.
Yeah.
It's part of the circle. So therefore, in this case, this is cosine 90, and this is sine 90. That's why sine 90 is 1 and cosine 90 is 0.
Okay.
So you get that. Anyway, so cosine 90 is 0, so this whole term is 0. Coming back to this one here. You see that?
Yeah.
And it works. 5 squared equals to 4 squared plus 3 squared, so it's working. Now let's try 4 squared. So 4 squared is 5 squared plus 3 squared, isn't it? Minus,
Yeah.
of course, this wouldn't work by itself, but with the 2, 5, 3, so this 5 here, this 3 here, okay? And then times by cosine of how much? It'll be 53.13. So let's see if it works. So this is about 16 on the left-hand side. So the right-hand side is 5 squared plus 3 squared minus 2 times 5 times 3 times cosine 53.13. So therefore, that's about 16, isn't it?
Yeah.
So we can see that it's working. It is working. So it doesn't matter what sort of triangle you have. This is sine rule, this is cosine rule, and they work. All right?
Yeah. And it's just about making sure you label it correctly.
That's right. So let's think about, so just a very important tip though. When you have a pair, if pair is known, it's better to use sine rule. You need to know that sine rule is easier than cosine rule.
Okay.
Sine rule, this is easier. So whenever you have opportunity to use sine rule instead of cosine rule, then use sine rule.
Yep.
This is harder to use. It takes more time. So if a pair is known, then use sine rule. What does it mean by pair? If a pair. So
Like big A and little a
yeah,
and
big A and little a, big B, little b. So these are, you have three pairs. This is a pair and
yeah.
that's a pair, okay? So if a pair is known, use sine rule. If you're given, if not, then you have to use cosine rule.
Yeah.
Let's say you have this situation, like 3, that's a 30-degree, and let's say this one is 4. Do we have a pair or not?
No.
No, then we have to use cosine rule.
Yeah.
So we have to figure out this one, we have to figure out this one, we also have to figure out this one here.
Mm-hmm.
Okay, so we can easily figure out what x is.
Yeah, so that'd be
Cosine rule.
yeah.
So x squared equals to 3 squared, 4 squared,
4 squared minus
2,
2.
3, 4 cosine of 30. See, that's working.
Yeah.
So therefore, x is equal to, that's a 9 plus 16 minus, that's 24 cosine 30, and square root that. So let's see what that is. Plus 16 minus 24 cosine 30, and then square root of that. That's about 2.05. Okay.
Mm-hmm.
Now, we also have to figure out this angle here. Now we have a pair. See how this one and this one is a pair now?
Yeah.
We can use 2.05 over sine of 30 equals to this angle. So I'm going to call that A. I'm going to call this B. This is a sine of A and 4 there, right?
Mm-hmm.
And then just move this one there, move this one there, move this one there. So it's cross multiplication method. So sine of A equals to 4 over 2.05 and then sine of 30 on top.
All right.
So what you get is 4 times by sine 30 over the answer.
Is that right? Because it's got a 4 times by the whole thing,
Yeah,
or not?
that's the same thing. Yeah,
Oh,
4
okay.
times by sine. This is the same thing as. Yeah.
Yeah, okay.
So,
Mm-hmm.
of course, we expect to have some rounding error because if we're using 2.05 rather than exact value of this.
Yep.
But let's give it a go. So 4 times by sine 30 and divided by 2.05. That gives us 0.9756. 9756. So that's what sine of A is. So A is equal to
Sine inverse.
Then we get about 77.3.
Yep. And that would be A's angle.
That's right. And then you do, 180 minus 30 minus answer. And you get 72.7 degrees.
Yep.
So it's almost an isosceles triangle. Because it's like 3, 4, and that these two angles are similar. Right. So one more thing you have to learn is that So in order to figure out angle, sometimes you have to use cosine rule to figure out an angle. If we rearrange this equation, cosine C is equal to, so it'll be a squared plus b squared minus c squared over 2ab.
Yeah.
Similar way, if you rearrange this one, you move. So what I'm doing here is moving this one to this side and moving this one to the other side. Then I get 2bc cosine A equals to b squared plus c squared minus a squared, right? And then you divide by this, then you get cosine A equals to b squared plus c squared minus a squared over 2bc.
Yeah.
Got it? So that's also very, very important. Of course, this one here is cosine B is, if it's B, then it's a squared plus c squared and then minus b squared. So if it's A, then you minus a squared. If it's C, then you minus c squared. And it's over 2ac. So let's use that idea and apply that to this case. So let's say you have 3, 4, 2 case. And I want to figure out this angle. Let's call that A. That means this is A, right?
Yeah.
So cosine A is equal to this one squared minus this one squared, okay?
Okay.
So it's minus the side square of the side that is opposite to the angle.
Yeah. So,
and then it's 2 times by 3 times by 4. So if you do that,
yep.
then 3 squared plus 4 squared minus 4, because that's 4, divided by, that's 24. Then you get this as cosine A, and you do inverse cos of the answer. Then you get 28.955.
Yeah.
That's the angle here. Now we have a pair. We can use cosine rule.
Oh, to find out.
Yeah, you can do this. I mean, on the sine rule, you can do the sine rule. Now, however, you know how sine rule was like a little a over sine of a, etc. You know, b over sine of b, and little c over sine of c. Now, in this case, we're trying to figure out not these guys here, but we're trying to figure out the angles, right?
Yeah.
So in that case, it's a lot better to flip the equation and just to put it as sine of a over a, sine of b over b, sine of c over c. Understand? This is a lot more convenient. So if I want to figure out b, then I do sine b over 4. And then I do, which one? Yeah, the pair, the known pair is this one here, right? So sine of
28.95
over 2. And this is equal to sine c over 3. So you can use this to figure out b, and you can use this to figure out c.
Yeah.
So look, so sine b is equal to 4 times by sine 28.955. Sine c equals to 3 times by sine 28.955.
Yep.
You know what to do from here, right? So 4 times by sine 28.955 over 2. And then inverse sine of the answer, 75.52. That's B. And then this one here is 3 times by sine 28.955 over 2. And then inverse sine of the answer. And 46.57. 46.57.
Yep.
That would be the C. Yeah. Is that all right?
Yep.
So if I add this and this and this, do I get, did I make any mistake somewhere? Doesn't seem like they're adding up to 180, 75.52 plus 28.955. Yeah, it's not adding up to 180. Hold on, there's some mistake that I made.
Oh.
Yeah, this one number seems incorrect. 3 times by sine 28.955. Maybe I missed some digit or something. That and then inverse sine of the answer. Well, that's right.
That seemed weird.
Yeah, 432. Hold on. Maybe there's a violation. 7. That's 5. Yeah, it doesn't violate triangle inequality. Hold on. Okay, so the problem is because, so the reason why this one doesn't seem to be working is because there are two possibilities. When you do this one, there are two answers, either this or something, either this or that, and then this one with this one works, and this one with this one works. So when you do inverse sine, so you see how B is inverse sine, so like inverse sine of that, and C is inverse sine of that, right?
Yep.
And then you get this one, but however, there is also another answer, which is 180 minus this one. So we're going to come back to that later when we deal with trigonometric equation later on. So it's 104.477. So 104.477. And you can see that this one with this one and then 28.955, 28.955 plus 46.57 with the 104.477 is equal to 180, isn't it?
Yep.
And if I do, I got this one, but if I do 180 minus minus this one, 46.57, then I get another answer, which is 133.43. And if I add that with this and then that one, then I get another triangle, and it's 180 as well.
Mm-hmm.
So I'll show you what that means. So it means there are two possibilities for this triangle. So one of them is, so this was all I was given. I was given this and this, right?
Yep.
I was given 3, 4, and this is 2. So this is 3, this is 4, and this is 2. So let's actually have a look at this red triangle, okay?
Yep.
So we have this triangle with B. B is acute, C is obtuse.
Mm-hmm.
So I think it's like that. With
Yep.
this being 4, this being 3. Of course, it looks a little bit incorrect. And this is 28 point, what is it? 28.955. And this one is 2, and this one is what? 75, sorry, 130. So C is 130 something.
3.43.
And this one is 75, right?
Yep. 75.53.
But it kind of makes this 4 shorter than 3. So I think this is not allowed. Okay, so the red one, I don't think it's correct.
Okay.
But for the blue, if we go for that 3, 4, and that's 2, then you see how that naturally that's 4, that's 3. You can see that this is an obtuse angle, which is that one there, that's B, right? And this is C. So I think this blue one is the correct one.
Yeah.
So, but in this case, this was wrong, this was right. But sometimes you end up with a scenario where they give you this. For example, this is 4, and this one is 3. And hold on, they give you 4. So this is the case where side angle is given. So you have side, and then an angle is given. So that means we have 2 possibilities. So let me think about this here. So one of the difficult situations is they may say, all right, this side here is 2. So this is known as the side angle case.
Yeah.
You don't get a definite shape sometimes. So this is 2, this is 4, and they may say, the angle there should be 30 degrees. But in this case, there are 2 possibilities. You can have 2, 4, 30 degree, or you can have 2 going like this, and this is the right angle there. So 2 can stretch out this way, or the 2 can stretch out this way. See?
Yeah.
So you end up with 2 possible triangles, one like that, and one like this. One like this. So to solve this, you can see that this is a pair, isn't it? 2 over 30, right? So we do 2 over sine 30, and then we do, to figure out this angle or this angle, you see how this and this are opposite to this one?
Yeah.
So if you are talking about the red triangle, that's opposite of this one. If you're talking about the blue triangle, you are talking about, that's opposite to this one. So we have this, let's call that angle A. And this is angle A as well, same angle, but of course different value. So A over, must be sine of A, and this is 4. Do you understand?
Yeah.
So to solve for this angle, you have 4 on 2 sine 30, so you get 1.
Mm-hmm.
Hold on,
Yeah.
let me think about this. This is a 2 of sine 30. So in this case, A is equal to 90 degree. So in this case, we get a 90 degree. So if you subtract 90 degree from 180, you also get 90 degrees. So in this particular case, we get just one choice. Rather than this choice and this choice, we actually have a 90-degree triangle. But let's say this was like 1, okay? Then what we get is 1 here. 1 over sine 30 is 4 over sine A. Then we get 2 possibilities. So you can see that A there, 4 sine 30 over 1. In that case, we get 4 times by sine 30 is 2. In that case, this is actually not allowed to be. Sine is not allowed to be 2. So what happens is I should actually make this something else, like 3. Sorry. I have 3 there. Then what happens is we have 4 over 3 times by sine 30. That gives us 2 on 3, which is 0.6666.
Mm-hmm.
Then if we take the inverse sine of that, you get 41.81.
Oh, okay.
And of course, if you take that away from 180, then you get another answer. which is 138.19. So you end up with two answers. So one for
Yeah.
this and one for that. So this is a difficult situation where you end up with two possibilities. So next time I'm going to talk about why when we do sine inverse we get two answers. The reason, just briefly, you know, the reason is, you know how when we talked about the unit circle, sine was, everything was positive here, and also sine was positive here, right? So
Yeah.
actually compute sine of 30 degree, that's actually the same as sine of 150 degree. They both give you the same answer. So if you do the inverse sine of this answer, you can get both this and this, right?
Yeah.
So that's the reason.